In December 2025, telescopes across the globe turned their eyes to the heavens, not for a supernova, not for a familiar comet, but for something profoundly different, an interstellar visitor, speeding through our solar system from the depths of another star system. It was catalogued as 3I Atlas, the third confirmed interstellar object humanity has ever detected. At first glance, it seemed like just another icy wanderer, another comet fading against the black canvas of space. But as data poured in from observatories worldwide, a strange pattern emerged. This was no ordinary comet. Its trajectory was unnervingly precise. Its brightness was fading when it should have been intensifying, and its chemical signature defied expectations. Suddenly, what was supposed to be a routine astronomical curiosity became a puzzle that challenged everything astronomers thought they knew. And yet, the world outside science began to spin a different story. On social media and video platforms, speculation ran wild. Was this an alien probe? A mothership? A signal from an advanced civilization? Tonight, we sift through myth from reality. Tonight, we ask the hard questions, guided only by science. And we examine whether, in the quiet halls of NASA and other observatories, some decisions or indecisions could have consequences far beyond what most of us realize. 3I Atlas is an interstellar object, meaning it did not originate within our solar system. Unlike the familiar comets and asteroids that orbit the Sun, this object came from deep space, traveling across light years before reaching us. Its discovery in July 2025 by the Asteroid Terrestrial Impact Last Alert System was initially met with cautious excitement. Confirmed interstellar objects are extraordinarily rare. Before 3I Atlas, only two had been catalogued: Oumuamua in 2017 and Borisov in 2019. Each of these objects displayed characteristics that challenged our understanding of how small bodies behave in space. 3I Atlas, however, presented a new set of mysteries. Observatories recorded it tracing a hyperbolic trajectory, which means it is on a one-time pass through our solar system. It will not return. Its incoming path was perfectly calculated, almost as if guided, and its approach allowed astronomers a unique opportunity: the closest encounter of an interstellar object to Earth in human history, without posing a collision threat. Analytical observations focused on three main categories: orbital dynamics, brightness and composition, and tail behavior. Each of these revealed anomalies that refused easy explanations. The first anomaly was its orbit. Unlike typical comets influenced primarily by the Sun's gravity, 3I Atlas displayed non-gravitational accelerations. In simpler terms, it was moving in ways that could not be fully explained by gravity alone. Small but measurable deviations in its trajectory suggested the object was experiencing forces beyond what astronomers usually account for in a frozen rock or standard comet outgassing. Most comets brighten as they approach the Sun. Solar radiation heats their surface, causing volatile materials to sublimate and form a visible coma and tail. 3I Atlas, however, did the opposite. Its brightness declined steadily, confounding expectations. Some initial theories suggested observational error, but repeated measurements confirmed the trend. This unusual fading raised the question: could the object's surface be coated with materials that reflect light poorly? Or could there be more exotic explanations at play? Spectroscopic analysis showed chemical signatures unlike those of typical solar system comets. While it did emit water and carbon-based compounds, astronomers noted an unusually low presence of typical dust particles. In addition, certain trace gases were detected that hinted at complex processes, possibly not purely natural, though nothing in the data definitively indicated life or intelligence. Perhaps the most visually striking anomaly was the anti-tail. Unlike conventional comet tails, which trail away from the Sun due to solar wind, CosmiqAtlas exhibited a brief, sharply defined antitail, a structure pointing toward the Sun. This phenomenon is rare and is usually explained by specific alignments and particle sizes. However, the persistence and clarity of CosmiqAtlas's antitail left many astronomers scratching their heads. Each of these anomalies, taken alone, might have been shrugged off as peculiarities. Taken together, they painted a picture of something unusual, yet entirely real and observable. It did not take long for the internet to respond. Within days, discussion forums, social media, and video platforms were filled with speculation. Some suggested it was an alien spacecraft disguised as a comet. Others theorized it was a probe, or even a swarm of smaller objects moving in formation. Part of this explosion can be traced to human nature. Interstellar objects are rare, almost alien by definition, and our imaginations fill in gaps faster than our telescopes can collect data. Additionally, the antitail and precise trajectory added an almost cinematic intention to the object's passage, which fueled sensational interpretations. It is important to separate what science actually observes from what stories go viral. No telescope has ever detected propulsion systems, transmissions, or signals from CosmiqAtlas. No credible evidence exists of artificial origin. Yet the combination of rare interstellar origin, trajectory anomalies, and unusual chemical makeup made it an irresistible subject for speculation. This is critical. Many videos and posts online falsely claim that NASA attempted a strike, a preemptive intervention, or even a weaponized response to CosmiqAtlas. These claims are entirely fictional. NASA's role was entirely observational. Instruments such as the Hubble Space Telescope, the James Webb Space Telescope, and ground-based arrays conducted remote sensing. Observatories measured brightness, spectra, and orbital data. No spacecraft was launched. No kinetic or directed energy tests were performed. Any suggestion otherwise is a myth. What did occur, however, was an intense scientific review. Researchers modeled its path, calculated potential risks, and shared data internationally, the standard procedure for any object of interest. The wrong decision in the thumbnail, if interpreted scientifically, refers not to an action taken, but to the deliberate decision not to intervene. The logic was simple. CosmiqAtlas posed no physical threat to Earth. Observation was the safest, most responsible approach. Even as myths proliferated online, the real concern among astronomers was settler. The unusual fading of brightness and unexpected trajectory corrections challenged fundamental models of interstellar objects. Each anomaly, however minor, suggested there are processes in the universe that are not yet fully understood. Some researchers began considering the possibility that CosmiqAtlas is fragmented, or part of a larger distributed system, a hypothesis called the swarm model. If true, this could imply that interstellar debris is far more structured and perhaps even technologically influenced than previously thought. It is not a certainty, but it is a possibility that must be accounted for in future models of interstellar objects. The swarm hypothesis proposes that, instead of a single object, CosmiqAtlas could be accompanied by multiple smaller fragments or components spread along its path. This theory arose primarily to explain subtle variations in observed brightness and the apparent gaps in its tail structure. Here, the debate becomes more philosophical than observational. Could natural processes alone produce such precise alignments, or is an artificial explanation remotely plausible? The scientific consensus leans heavily toward natural origins, noting that our understanding of cometary physics and interstellar debris is still limited. However, the debate highlights a broader truth. Interstellar visitors may not fit neatly into our terrestrial categories of expectation. Even the discussion of artificiality is conducted quietly in professional circles. No public announcement claims extraterrestrial intelligence, but the anomalies are real, reproducible, and scientifically intriguing, enough to warrant careful monitoring. 3. Atlas matters because it forces humanity to confront the unknown with rigor, not speculation. It reminds scientists that our models of the universe, while powerful, are incomplete. It compels improvements in detection methods, observation networks, and our theoretical understanding of interstellar physics. It also matters because it represents a rare cosmic message in motion. While it is not communicating in a language we can decode, it communicates through behavior, through deviations from expectation, and through the subtle hints hidden in its chemical and physical properties. Each anomaly is data, a whisper from another part of the galaxy that expands our understanding of what is possible. Observations of 3I Atlas will continue long after its closest approach. Future interstellar objects will benefit from the lessons learned: vigilance, patience, and an unwavering commitment to separating myth from data. As the last images from December 2025 were analyzed, 3I Atlas moved away from the inner solar system. Its brightness faded further, leaving behind only the faintest traces in telescope archives. For now, it will drift back into the darkness between stars, a silent witness to the vastness of the cosmos. Yet its impact remains. Scientists continue to debate its anomalies, model its trajectory, and speculate about what else might be out there. The internet may continue to spin wild tales, but the truth, calm, meticulous, and measured, is far more compelling. 3I Atlas is a reminder of our cosmic humility. It is a call to observe, to question, and to embrace the unknown without panic or assumption. It is both ordinary and extraordinary, a fleeting messenger from the deep, dark ocean of space. And as we watch the sky tonight, binoculars in hand, telescopes online, we are reminded: the universe is stranger than we imagine, and every anomaly carries the potential to teach us something profound, if we are patient enough to listen.